Seth here, and I'm going to be talking to you about area charts and packed bubbles. So, in our last lecture video, Kate talked to you about visualizations that help you maybe illustrate one distributions in particular. Area charts are sort of really nice segues from that because they actually have the capability to show you multiple distributions and how they relate to each other, and also talk about those distributions collectively because they signify something as well, and hopefully they'll get a lot clearer as we go about this video. So firstly, what are area charts? Area charts are these visualizations right over here. So they're almost variations of line charts in more ways than one, because at the end of the day you do have lines that show you some variation of a numerical quantity over a certain time period, but the only big difference being that you can, one, this area charts add a sense of volume to your data because you basically have the area underneath shaded in, and they also simultaneously allow you to see part to whole relationships because both the aggregate of all the data and individual categories can be shown in area chart. So the area chart we've seen over here basically aim to illustrate two things. One, the total number of fruits sold, as you can see, over say 5 days. They haven't marked the days over here, but you can think of A, B, C, D, and E as just being 5 separate days. And you can also stratify by fruit. So you have a different colored area chart for each fruit with the key over here telling you what color corresponds to what fruit. So one thing to note over here is that the top of the graph tells you about a much bigger trend, about the total number of fruits a particular store has sold maybe on 5 different days. But you can actually look at the different colored parts of the area chart and observe trends and proportions that each category correspond to as well. So this tells you two things. It tells you that from day A to day B, your total number of fruits increased from 16 to 22. But you can also look at distributions within those total number of fruits. On day 2, did I sell more oranges? Did I sell more apples? Did I sell more apples on day 1 relative to day 2? So area charts convey a lot more information because you're now basically demarcating categories by colors and then stacking them on top of each other. So the summation has a significance as well. Here it's the total number of fruits sold, but individual categories tell you something about individual trends as well. So hopefully that gives you some bit of added functionality. Now about how we'd implement area charts in Tableau. So very similar to a line chart, we need to have time series data on our x-axis, and that's going to be a column measure. We again need one measure on the y-axis. That's basically what we're seeing the trend of. In this case, it was total number of fruits, but it can be anything you want it to be. And we also need an additional dimension. Now with a normal line chart, one measure and time series data would be enough to make your line chart because you didn't have that additional categorization between categories. But in area charts, you need another dimension to stratify by. In this case, that added dimension would be a type of fruit. Are we talking about plums over here, grapes, apples, oranges? So we need one more dimension. If you remember from our first lecture video, dimensions are qualitative data to basically reap the benefits of an area chart against a line chart. You can have zero dimensions in theory. There'll just be a line chart with the area below shaded in one color because you don't have any dimensionality to the data. So you can also add more measures, but what they'll do is they'll just create another additional area chart for every other measure you add. So if your first measure was, say, the number of fruits you were selling, and you had another measure, let's say the number of customers that enter your store every day, then you'd have one area chart for the fruits and another area chart for the customers. So since you're fundamentally measuring different things, it wouldn't make sense to have those two in the same area chart. And hopefully they'll get a lot clearer as we move on. So the data set I'm going to be using to illustrate area charts to you in trying to keep up with relevant data sets is basically is a coronavirus related data set. So what this data set does is basically tells you about trends in California counties, the total number of confirmed cases, the total number of people who died each day, and then a lot of other measures. We have like suspected coronavirus patients, then we have patients in the ICU. So we have this data, but it's basically stratified by county and day. So for each county, you'll have a date associated with it, all these parameters for each day for a particular county, and you have that across multiple counties in California across many days. So this data set I think ranges from, let's see, 1st April to 11th April, so very recent data set, and you have all these parameters stratified by county. So San Diego will have one row for each day from the 1st of April to the 11th of April. Now to illustrate an area chart, I've basically narrowed this data set down to only 4 counties, namely Santa Cruz, Santa Clara, Santa Barbara, San Mateo, and San Luis Obispo. So 5 counties, I'm sorry. And what we're going to do is I've already loaded this data set up on here. And we're going to create an area chart to hopefully illustrate a trend of the total number of maybe coronavirus cases we've seen in these 5 counties put together. But because we're stratifying by county as well, we can hopefully see individual trends that relate to each county. So you can see maybe the trend in Santa Cruz in particular in relation to the total number of cases in these 5 counties. And again, this gets back to the point of how area charts differ from line charts. You can illustrate part to whole relationships on individual trends in categories as well, and not just the overall trend of the sum of some sort of data. So let's move on to Tableau then. I already have this data set loaded on for you. So we're going to create a visualization. Just going to click this button over here. And what we want to do is basically add our dimensions and measures now. So what do we want our columns to be? We talked about how your columns should basically be your time series data, and the only time series data we have in this data set is the most recent date. So we just drag this over here, drop it. One thing you do want to note is Tableau gives you the option of selecting what parameter in the date you want to stratify by. Since this is only 2020 data, it wouldn't make sense for you to select year over here, since all data points correspond to 2020. So it doesn't really make any sense. You want to stratify by day and not year. So you choose the day column over here, and now you get one entry for each basically date in our data set, April 1st to April 11th. Now what do we want to measure? Let's try measuring just the number of positive confirmed cases we have. And we can add this. And this gives you a normal line chart because we haven't added the stratification over here, have we? This is just a normal line chart because we don't have any individual categories we've defined yet. And to do that, like we've talked about before, we need to add one dimension to our data, something we can basically stratify by or categorize by. And that in this case is going to be our county name. So what we're going to do over here is just take county name, drag it over here. You get multiple line charts over here. What you want to do is select area chart, and you get an area chart. So as you can see, you have an overall trend of the number of coronavirus cases in these 5 counties put together, and you can see we have a slow increase over here and then what seems to be a decrease, but you can also see individual county-wide trends. So for example, Santa Clara actually seems to have the majority of the cases of these 5 counties, and you can see individual data points that relate to a particular county as well. So you can see the sum as the trend of the topmost line and individual data points for each of these colors as well. So hopefully that teaches you how to make area charts. I talked about how if you add another measure, what will happen is this will just create another area chart. So let's try and add another measure. And the second thing we're going to be measuring is maybe the total number of deaths in each county as well. So if you add that as a measure, the sum of total deaths, you get 2 area charts. One that corresponds to basically the number of confirmed positive patients and the total number of deaths. So really useful visualization in illustrating both an overarching relationship about the total number of cases or maybe the total number of deaths in a set number of counties, but also telling you a lot about individual trends within that sum that a line chart wouldn't. And just to again drive that point about how this varies with a line chart, if I just converted the same data to a line chart, you get 5 different line charts. But the only thing is, there is no measure telling you about what all these 5 add to, because you haven't stacked them on top of each other. But with area charts, you get the exact same information. You can see individual trends for each county, but they're stacked on top of each other. So you know the top of each area chart tells you about an overarching trend as well, about how maybe the total number of patients in these 5 counties have increased over time. And in here, the total number of deaths these 5 counties have increased over time. This is obviously only upward sloping because the total number of deaths cannot decrease. But hopefully that tells you about one advantage an area chart has over